Well, hi, good morning, and thank you so much for joining me in my shop. Today is May 24th. That's an important day here in Canada. We have a long weekend called the May 24th weekend. So people are going to enjoy a long weekend this weekend. So, what to do about this radio, which appears to be less and less broken every time I work on it, even though I'm not doing much to it. Well, changing a lot of tubes, actually, is what I've been doing. So I think the next thing to explore is the FM detector circuit, and we'll take a look at the schematic and see how it's wired up. Then we'll see what it is we might be able to do, or where problems might come, or what kind of tests we could do to prove it's good or not. And we'll go from there. So the first thing is we need to look at the particular circuit that they're using for the discriminator in here. Fortunately, this radio is not stereo, so there's a lot of complicated stereo stuff that will not exist in this radio. You're going to keep knocking it down? Hey, I thought you liked the stick. I thought the stick was your thing. No, maybe. Sure. Okay, let's take a look at the schematic. We'll start there. Well, once again, my shop is being taken over by the brothers. Here they are. This time of the morning, they're very active, and they're looking for stuff to do. And it looks like they're going to find it here in my shop. But while they're playing around there, oh my gosh. Yeah, nothing like some wires. Oh my gosh, you guys. So my strip lighting system is shot down here. I have to remove it because they just won't leave it alone anymore. To you guys. Can you tell they're brothers? Is there any hint that they're brothers? Oh my gosh. Okay, Mr. Entertainment. We have to get back to the dealing with the real problem here. What do you? He's gonna work my camera the whole shot. Wow, camera crew. Yes, we'll call them the camera crew from now on. Okay. Enough cat craziness here. What are you doing? Well, we might be hearing the cat noises in the background while I do this. So this service manual comes with a section on each part of the radio and a description written by the designer or the engineer of how it works. So here's the section on the FM channel and meter control circuit. So let's just, it's a fair bit to read through here, but let's go through it. The FM channel employs an EF94 6AU6 high slope pentode as a limiter, and an EB91 or 6AL5 as a Foster-Seeley discriminator. There we are. The limiter function effectively even with very weak signals. Sorry, let me read that again. The limiter function one more time, Jeff. The limiter functions effectively even with very weak signals. That doesn't seem to be the case, does it, with this radio? And the discriminator characteristic is linear over a bandwidth of at least 180 kilocycles, so that any standard deviation can be accepted without distortion. But it is distorted. The circuit features de-emphasis in both FM positions. De-emphasis is a technique for simple technique for ending up with less noise. Audio from the FM and AM channels is taken to S1J, which selects the appropriate outputs and routes it via C. I'm not going to read this stuff here. This is also present, blah blah blah, portion of the AM signal strength to receive carry in the case of FM signals portion on this tuning, appropriate voltage applied, blah. Okay, let's go down a little further here. This stage is wired as a cathode follower and has a very sensitive 1 milliamp meter connected from point. They're talking about the meter stage. We don't really want to read about the meter. We just want to read about the FM part. When the FM mode switch is set to the FM positions, the bridge is unbalanced by the operation of S1I, which modifies the cathode connection of the meter circuit. Okay, the degree of unbalance is controlled by R89, which is set such that in the absence of a signal, the meter needle takes up a mid-scale position. So I think what they're kind of talking about here is the technique they've used to make a meter operate as both a AM signal level meter and yet somehow function as a center zero meter under other circumstances. And that's a little bit of a tricky thing to do, because this meter naturally relaxes to the left side. It doesn't relax into the middle. So they've done some technique here to get it to be a center zero meter. Probably there's a zeroing of the meters. Probably there's an adjustment on the back here, which is called AM zero, and there's another one called center zero FM. So there you are. So right on the back of the radio. The degree of the meter now only serves as a tuning indicator. Signals are tuned such that the meter needle lies on the red line, which corresponds to the mid-scale position. This is the condition when the DC output from the discriminator is zero, as is the case when the carrier frequency coincides with the center frequency of the discriminator characteristic. The discriminator characteristic curve of the coil that's responsible for it. They didn't put that last little bit in. If a carrier frequency does not meet this condition, there will be a DC voltage, and when applied to the grid of V1 to cause the meter to swing left or right. Okay, so the big deal here is a Foster-Seeley discriminator. So I think we need to read up on a Foster-Seeley discriminator a little bit. Oh my God, Cassie, just non-stop playing with something. Let's get a little bit of artificial intelligence help here.
Hey Jim.
Hello.
Morning Jim. How's Saturday shaping up for you?
Saturday's shaping up like most Saturdays do. So I have some questions about FM detectors. Are you ready?
Absolutely Jim. Fire away.
So the radio I'm working on has a type of FM detector called a Foster-Seeley. What can you tell me about that?
The Foster-Seeley discriminator is a type of FM detector used to demodulate frequency modulated signals. It works by converting frequency variations in the FM signal to amplitude variations, which can then be processed to recover the original audio. It's known for its good linearity and is often used in older or more traditional radio designs.
Okay, so the radio I have has some distortion in the FM output, and I have not been able to track down the cause. What would I look for in a detector like that?
Oh, no worries. Distortion in FM could result from several factors. First, check the alignment of the discriminator. It needs to be correctly tuned to the FM signal's center frequency. Then inspect the components, particularly capacitors and resistors, for any signs of damage or drift. Also, consider the signal strength. Too strong or too weak of a signal can lead to distortion. And don't forget the power supply. Unstable voltage can mess with performance.
Okay, thanks.
No problem.
Are you still there? Good, I just like to make sure that when she's gone, she's gone. So, well, that wasn't terribly helpful. That didn't really tell me much more than I already realized. That was kind of a general statement. It's true of just about all discriminator circuits. So I really think we need a circuit diagram to look at and try to understand a little bit better that way. She mentioned this distortion in FM can come from all over the place. Strong signals, weak signals. And this radio never seems to quiet during when it's receiving an FM signal. There always seems to be a bit of AM noise coming through, which suggests the limiter circuit isn't working properly, but who knows? So let's take a look. I'll look for some standard examples of a Foster-Seeley discriminator or detector, and then we'll study that. I'm sure I've read up about these things a few times over the years, but every time I encounter one, I sort of need to refresh my knowledge. So here's another source of knowledge about a Foster-Seeley discriminator, also known as the phase shift discriminator. That's an important thing to recognize. Phase shift discriminator. Electronic circuit used for frequency demodulation. It converts frequency variations in an FM signal to amplitude variations. You know what? That's not actually demodulation. That's just converting it from FM to AM. This part of it, the AM, which are then rectified and filtered. Well, that would be where the demodulation takes place. Okay, I'm kind of splitting hairs here. This circuit typically employs a double-tuned RF transformer. It is widely used in radio receivers for demodulating FM signals. The Foster-Seeley discriminator is known for its effectiveness in providing a clean output signal from frequency-modulated inputs. Clean signal. Mine's not clean. Double-tuned RF transformer. Be careful there, guys. Double-tuned RF transformer. So when I did the FM alignment process, I was tuning the primary and the secondary of this transformer they're talking about. Tuning or adjusting. Okay, but I really like to see a diagram. Here's one. Oh, here's a whole bunch of them. Here we are. Let's grab this one. Okay, so a couple things here. Notice the diodes are pointing in the same direction. And there's a balance required. These resistors have to be exactly the same value. Likewise, the diodes have to be operating the same. Capacitors have to be in the same condition to get a balanced output. RF choke down here. Let's see if there's another diagram of it. Doesn't look like it. Looks like everything else is power supplies and stuff down here. Okay. I'm gonna get the same diagram again, I think. So here we see primary tapped secondary. Look at the tap is going in a different direction in this diagram. Appears to be going in a different direction. The two resistors, two capacitors. Notice there is no large capacitor shown here. Often with FM detectors, there's a 4 or 5 microfarad capacitor across the output. It's not in this one. The center of the secondary coil is connected to the top of the primary coil through capacitor C. This capacitor C forms the following functions. This is the one they're talking about here. It blocks DC from primary to secondary. It couples signal frequency from primary to center tap of secondary. Yeah, it does. It takes the signal from here and sticks it into the center tap of the secondary. The primary voltage, the signal voltage, thus appears across inductor L. This is inductor L. Nearly entire voltage V3 appears across inductor L, except a small drop across the capacitor. Not quite sure what they're saying. A small drop here, and so the voltage appears across this when you fed in the center. However, by a suitable choice of C and L, the voltage drop across the capacitor can be made negligible. Oh my gosh, it's not helping me at all. Phasor diagrams. Move on quickly. At resonance, when an input voltage has a frequency equal to the resonant frequency of the tuned secondary, V3 is in phase. Oh yeah, quadrature. Okay, I'm not going to try to swallow this. These are a little complicated to understand in detail. I don't care to do that right now. So the main thing is finding these components and making sure they're in good shape. Something way out here would cause some distortion that we could not overcome no matter what. So we need to find this circuit now in the radio's schematic. Okay, so this is the rectifier tube involved with the detector, and this would be the coil, the double-tuned coil. Excuse me, here's the center tap on the secondary, but it is not going back to the primary, it is going forward. And I think this is where the output is developed, right on the R49, and is then transmitted out of this stage and on to other stuff, I think. Through the switch here, maybe, I don't know. So where are the double resistors? Where is the double capacitors? Where is all that stuff? I don't see it. Instead, I see the output coming straight to these two plates in the diode. They doesn't seem to match particularly well at all to the standard diagram we were looking at. So it describes it as a Foster-Seeley detector, which means it's related to phase shifts of the signal as it comes through here, and those phase shifts are utilized to generate the audio signal that we're looking for. That's my rough understanding of it. Look, here's a capacitor going back from the center tap. Right off the top of the limiter tube here. Yeah, I cannot explain the operation of this. Now what are we going to do about it? Here's a couple of resistors, but I don't think the resistors I'm looking for would be on this line. These lines, wouldn't it? Now I can't remember what the detector looked like. Can we find it quickly? What's all this stuff that's come up? Here we are. So, center tap, capacitor across the secondary, capacitors, resistors, output across the whole thing. Output across the whole thing. Now, can I find the diagram we were just looking at? It just doesn't seem to be built in the same way, does it? So there's not a lot here to deal with. What could be out of sorts that would cause distortions? I don't know. I don't know. I don't know what. And unfortunately, the IF's coming through here at a high enough frequency. Some of my equipment can't reach it. 5.2 megahertz through here, and I've got broadcast radio stuff here. I can't utilize it exactly. What can we do here? Well, something I could do. I can feed in a controlled signal from an FM generator I have, an FM simulator, in fact, it's called, and we can know that there's a good modulated FM signal coming through the radio. We could then get out the scope and scope this stuff, but how accessible is it? V9, I think it's in an accessible location. V9. Yeah, I think it is as accessible as anything is in the radio. What will we get from that? What could we possibly do here? Another thing is that going back to the IF output, which disappointing to find out the terminal on the back of the radio is actually connected to the mixer, but I would like to know what's coming out of this IF string. Okay, I get too much stuff in my head. I gotta stop for a bit. I think the coffee's ready anyway. I'm gonna drink a little bit of it and decide what to try next on this. Okay, let's see if we can find some of these parts in here. So V9 is the FM discriminator. V8 is the FM limiter. So V8 and V9 and V8 and V9. V8 is right here. And V9, I think, let me get my flashlight here. V8 is here. This is V9. V9 is a 6AL5 I've looked at before. V8 and V9. Okay, let's tip this up and see what we can find. Easier. So once again, V8 and V9. get this wrong. Yeah, either side of this can. Okay, so they are up in here. V8 I've looked at. Oh boy. Yeah, I'm gonna find stuff in there. Holy smokes. What am I gonna do in this thing? Oh my gosh. Wow. Let's say this is just full of stuff here. Wow. I'll give you the poor man's 3D view of it here. Where's my camera will focus. If I just get the camera moving a bit, you'll get a depth perception of what's going on in there. Yikes. Holy smokes. And then up here, where neither of us can see, there's going to be stuff. I bet. Wow. Well. 450 million year old rock on the floor below here that's interfering with my tripod. Okay. What are we going to do in here? Very, very careful inspection of parts. Whoa, how can this fall over? This can't fall over. I had a small heart attack there. There. And all these parts, the position they're in is where they have to remain. Or there's a risk of disturbing the circuit operation accidentally. Wow, there's a little diode way back in there. There's these weird capacitors that are just out in the open. There's one here. There's a couple more down here. They aren't enclosed. This one almost seems to be in contact with a brass bar that's running across there. And just in behind it is a glass diode. Way at the bottom is a capacitor. Oh my God, you could never get in there and do anything about anything in there. Holy smokes, you'd have to be taking off side panels. Well, maybe that's how this is made. Yeah. Well, maybe you get the side panel off and then everything is easily accessible. Maybe that's the trick. Okay, looks like a lot of work to do that too. Yeah. Okay. And looking for some reason for me to go in and do all that. So the 6AL5 was in this position here, and I'd really like it if I could find a burned open resistor. That would be really nice. See anything here that's gonna yikes. Well, so the 6AL5, I think, isn't that the detector? 6AL5 is the discriminator, right, and the limiter is a 686, and so it's V9 6AL5, which I'm pretty sure is this guy right here. And there are two identical resistors coming off it, and What about two identical capacitors? But the schematic shows something quite different. There are two identical resistors coming off it. These two here. There's also two identical ones here, which I spotted yesterday and thought that would be the ones, because they came up to the switch here, which matched the schematic. What are the other two identical ones that are in series, basically? These two in series. Brown, black, yellow. That's 100,000. 200,000 ohm resistors. And these ones were 68K. What are the 100,000 ones doing? Let's take a boo at the schematic here. So I'm seeing two identical 100,000 ohm resistors, and I didn't put the values on here. Two identical. Let's use this one. We'll go down to the parts list. And we'll look for some identical resistors that probably are numbered very close, like this, 4041. And that's a 100,000. Maybe I found them. could it be that quick? 4041. 4041. And we're looking at, where am I here? Here we are, 46. Oh, this is 4647. These are, or 4847, the 68s. 4950. And 50, 50, way up here. 100,000. 100,000. 49 and 50 are the 200,000s. Now, what are they doing? What are you in there for? Well, interestingly enough, it looks like I don't know what I'm doing here. Oh, did he say cathode follower? In the it did say something about cathode follower. It's a cathode resistor here, and maybe this is where the signal is being developed. That's being passed on. I'm not sure. I'm not sure what's going on. I don't know what's going on. Okay, let's accept that. I am not going to know what's going on exactly, so my ability to pick this apart, like do a test and then analyze it, is going to be very weak. Oh my gosh, I got nowhere to go with this thing. I did talk about feeding in an FM signal. It's just a sine wave again. I don't know what to do. So I'm going to stop for a bit, and maybe we'll play around with the signal generator and just see what we can do here. Hey, here's a little secret you probably don't know, and I didn't know it if you're Canadian. Hey, surprise. We have a high-end chip industry in Canada. I didn't really realize that. Canadian manufacturers make a small volume, very high-end, very specialized chips for industry, especially industries. And we have a very fast prototyping and testing facility and manufacturing facility for chips here in Canada. Oh, who knew? Shh! Don't tell any Americans that we make chips here. Oh. Well, I still don't know what to do now. Yeah, I was going to hook up the signal generator. Right. I do know what to do. I just forgot. Okay, my cat won't leave me alone here. Let's turn on the radio. Let's try that again. Okay. Bird here just can't seem to get enough affection. So we're going to use the signal generator that's back here, right behind the radio. No. Maybe you better come out now. What if I throw it? What about your stick? I'll throw your stick on the floor. You watching? Hey. Are you watching? No, you're watching me. Watch. I always got it. Cats have the fastest reflexes of animals, which is why they can catch flies and we can't. We're not fast enough. Okay, you ready? Here you go. Go for it. He just looked up at me like, what'd you do? You were playing with that stick and then suddenly you just threw it. People, we don't make any sense to them. I have to let this warm up a little bit anyway. We make no sense, do we? All that noise coming out of our mouths. What's all that about? Okay, 100 megahertz. Oh, band 2, 100 megahertz right here. Here, there we go. Okay, so just tuning through, you can hear all kinds of weird, like, variations in the... especially that. So when I first started working on this radio, the meter seemed to work, just not in a calibrated way. Get that thing. Holy smokes. Better than a mouse. Now the meter doesn't work at all. It never responds. That's another problem worth looking into. Does that have some bearing on all this? Could it? Could it have some bearing? There is a tube driving the meter and some complicated circuitry to achieve the center zero and stuff like that. Could any of that come back on the sound? You wouldn't think so offhand, but who knows, right? You wouldn't think so, because you think the engineers would kind of isolate the meter operation away from the audio and the radio and all that. What are you doing over here now? He's going, hey, what are you doing? Come on, get back over here. You got a stick, play the stick. Look at this, look what you did here. You beheaded my clip lead. Okay, you're on your way now? Is that you're deciding to leave? Yeah. No. Let's go. Come on, you gotta go. You worn out your welcome. First the front half, now the back half. Here we go. That's the back half. Part of the back half's missing. Okay. Down you go. Here's your stick. How about that? If I give you my stick, your stick rather. Bert. That's it. That's all you're getting. Okay, that's good enough. Okay, Bert will be occupied now for 3 minutes. So I have this receiving. It's hooked up the way the signal generator wants to be hooked up, straight to the antenna, but it sure sounds like it's being overpowered. Let me turn down the IF. And we put a more pleasant tone on here. It sounds like it's crying. Now you can really tell that this should be a nice pure sounding tone. It really doesn't sound pure at any moment. Right in there. Still doesn't sound right. Well, how come? How come it doesn't sound right? Okay, I keep skipping past this thing about output of the IF and can we hear it? And yes, we can hear it. I can pick it up with my SDR, and we can even run the SDR detector on it and listen to whatever this thing is tuned in. if there's anything there to tune in. So I could do this. What would I hope to find out? I find out it's certainly not in FM, but in AM mode, there's still distortion. I don't even know that that's the case. Is there really distortion in the AM mode? I don't even know that. There's another thing for me to eliminate. Flip to AM. Incidentally, we shouldn't hear any of this now. A really good radio should be silent. Shouldn't hear any of that. So yeah, that's another indication that things are just not right. That's a help. More help. Oh no, they're back. But yeah, 3 minutes, just like I said. I'll hold them for 3 minutes. Okay, finding out the sound quality of the AM side of this radio. Okay, we're switching off the FM detector on the AM detector. Feed in a wonderful signal. Stick it on a scope. Take a look at it. That's the plan. That's all I'm going to do. Let's forget the FM side for a minute. Let's see if we can make the AM side work. Besides, am I going to be listening to FM with this radio? I'm more likely to be listening to the AM side of it. Now that I think about it. I should think about things a little more. Okay. Okay, so my conclusion is spending time on the FM side of this radio is really kind of a waste, in fact, because the signals I'd be listening to, aircraft, stuff like that, is AM, not FM. And if I want to listen to an FM radio station, I don't think I'm going to use this radio to do it. So maybe my whole concern about FM has been misplaced entirely. It started when I initially had the radio, and the only thing that made any noise was setting it to FM. And so I sort of got caught up in the FM world in this radio. At this point, by looking at it, I don't know what's going wrong. I don't know what to do about it. And trying to figure all that out is almost impossible because the parts are just buried way down in here. I'm more likely to make more mistakes than to benefit the radio at all. So what am I doing? So I'm really barking up the wrong tree in a sense. We're going to forget about the FM side. We're going to look at the AM side, which I was surprised to learn appears to work. It also seems a little bit weak, but I'm not even sure of that. I picked up some CB radio with it. This radio only goes down to 19 megahertz. So, wow, really, there's no shortwave broadcast above 19. There's a little bit going on at 17 megahertz you can pick up. So as a shortwave broadcast receiver, it's not happening either. Aircraft is really what this guy would be used for, I think, in my world anyway, for picking up aircraft. So I do have a scanner running all the time in the other end of my house with the volume turned down low, and it's just picking up aircraft at 127 megahertz, exactly that frequency. And okay, this guy can do that. Yeah, really, I'm thinking, just kind of reversing my thinking, if that makes any sense. Going after the FM first is kind of crazy. And I explain how I got there by accident. You should be focused on the AM side of things. Simply because it's simpler. Okay, having said all that, now, how do we determine if this radio is actually working? Because I did pick up some CB stuff, and the signal being presented to the radio may have been weak. We need to find out if it's distorted and if it's weak. Pretty sure it is, because I think I always have the volume turned very high. And there's no real sample signals except CB, which is really a crummy thing. Gee, I wonder if the CB thing's happening right now. I'm going to go check. Is the skip coming in? Okay, it turns out the CB is going. So let's see if we can pick it up too. And we would do that on band number... Actually, band... If you get it up here... on band 6 or down here. I think band 5 is probably better to do it. We can try both in the end. Band 5. Band 5, and we'll go down right around 27 megahertz. There we are. IF gain up, audio up. We're on AM. Some funny tones come out of this radio. Come on. Got it last time. Trimmer. Yikes. See, I would hope we would hear some kind of, let's use FM to adjust the trimmer. AM. Volume full. Got no more. It's got no more. It's got nothing. Channel 6 on CB is where the big guys hang out. Assumably the guys with extra power in their radios. This is not picking anything up. Have I for sure got this connected properly? Hooked up. Yes. Huh. Not a thing. What's happened? Well, it just goes to highlight how weak this radio really is. Like, we should be hearing a hiss coming out of here now. Yeah. Phooey. Somehow I was hoping we would hear something. Now the CB radio I went and checked is hooked up to a tall whip, a separate antenna just for that radio. This one's hooked up to a different kind of antenna, a mini whip antenna, and its limit is 30 megahertz, so it states, when I'm up near the top of that. We're not going to hear a thing. Nothing. So what I could do is I can force this radio onto the correct frequency. You know what's possible here? Weak across all bands. A local oscillator could be weak. A local oscillator could be weak. That would be weak everywhere then. That would explain everything. Maybe not the distortion in FM, but weak oscillator. So who's oscillating? The oscillator is this guy here. 6885. So the tube could be weak, the oscillator circuit could be weak, or I could just be barking up the wrong tree once again. How do we know if this is working well? How do we know if the oscillator is strong? It's a really difficult problem in any radio, determining if the oscillator is strong. Since I have no experience with this radio or anything really like it, trying to pick it up using a coil, just picking it up out of the air, basically near the radio, what's that going to tell me? Is that going to tell me it's strong or weak? No. Can you even do it? So the IF is 5.2 megahertz. That means the local oscillator runs that frequency above or below the incoming frequency. Why don't we go look for it? Why not? So it's the tube involved is hidden under this shield cap right now. But I can slip a little coil in under here, probably get a little bit of signal onto it, and probably get it onto the SDR that way. I don't know what else to do, so let's have some fun. I'll try this. Just in the middle of getting things ready, and oh, my cat is showing up. And I went to tune the radio to a different frequency, and this is what I started picking up. Well, what's going on there? This would be, just to see, make sure, where I am, band 5. So around 30 megahertz. So is that picking some? Is this picking something up from? Let me disconnect the antenna. Is this coming in on the antenna? Yes, it is. Wow, the radio's responding to something. Oh my gosh, Bert. Pet me, please. I need a pet. You don't need the reassurance. Okay, scram. Scram. Go over, go under. That's it, walk on the keyboard. So, what's going on here? I got all excited because the thing started picking up what sounds like atmospheric noise. I can just do this. Yeah, it's definitely coming in on the antenna. So it's picking something up. It's just noise. So let's just make sure everything's up as high as it can go. What? I need to get a little more volume out of this thing. I think we might find out that it's actually doing a better job than I realized. Of course, getting more volume out of it would be a better job. Well, I don't know why, but it likes the noise right there. And then we get up to 27 and it's all quiet again. Anybody there? What's he doing? I think he's watching the pointer move back and forth. He's thinking, how can I get that? How can I get that? No, you can't get that. You shouldn't even be up here. Okay. Back to what I was doing. What was I doing? I was going to look for the local oscillator on the SDR. I'm just going to put the whole SDR up on the screen here. Here we are. That's the whole SDR. You see, the tuning point is currently 35 megahertz. So if I tune past 35 megahertz, and there's a local oscillator signal to be seen, it's going to show up. Okay, so I'm up to 33. I haven't even got above it yet. 34, 35. It's a lot of work here. 38. Nothing's showing up at all. Okay, so let's think about this. I got up to 40. The local oscillator is running at 5. Could be 5 above. Well, then if that's the case, this should really work when I'm tuned around 30. I should see it around 30 if it's above, if the local oscillator runs above. So I'm going down to 30. Happens to be the noisy area. And my cat has gotten really interested in the pointer here. Well, I don't see any local oscillator, but I'm going to stop. I'm going to rearrange my screens here. Okay, I just realized what the sound was I was hearing on the radio. The sound went away as my air conditioning fan stopped. So that was the interference coming from my furnace fan control system, or whatever it is. Okay, and I also have something. This is just, I'm going to show the cat this thing here. He's just going to go nuts over it. I know it. Right now he's busy chewing on my wires here. Come on. Look, these are good wires. I don't want you chewing on it. Come on. Look at this thing. Look at this. Look at it. Look at this thing. Look at this. What is that? Hey, what is that? Come on over here. Come on. I say in my commanding voice. Come on. He's trying to work the camera now. Hey, hey. Okay, that should keep him tied up for a little bit anyway. Okay, so interference sound was the furnace. Now, I've had this pickup coil sitting on top of a shield plate, which is kind of silly, but the tube we're interested in is down under here. If I just stick this in here, we're liable to pick some signal up, I think. Let us see. Now, tune the radio and see if anything's moving. Nothing's moving. And where are we? So on the SDR, the center is around 35.5. And I'm dialed in here at 30. So that should put the local oscillator. Oh, what was that over on the left there? That should put the local oscillator on the screen. So I'm looking for anything that's moving. See, no movement at all. Some of these SDRs, you have to operate them above 30 megahertz. You have to make a change. There's little tiny blips of signal showing up on the SDR, but I don't think they have anything to do with what I'm doing. Okay, so what if the local oscillator is below? Well, if it's, then we would want to be up around 40, and that would give us a local oscillator running around 34 or something like that. So yeah, look at a little signal showing up on the left of my SDR there. Where'd that come from? Oh my, wait a minute. That is the local oscillator. I'm just moving it too fast. There it is. Okay, so in case you don't know what I'm talking about this right in here. This line right here is the local oscillator. Let's see if I can move the coil around, get a better shot at it. No, weaker there. Ooh, much better there. Okay, so we'll put it there. This probably isn't disturbing the radio at all. Now we can see the local oscillator frequency. So first thing we know is the radio is tuned to just below 30, and the local oscillator is just below 35. That makes perfect sense. If we actually take the frequency here and carefully assess it, we could say 34.6, couldn't we? A little off at 34.6. Oh, you know what I can do? I can make this real easy. If we put this to some nice number, let's see, 52, what about 34.2? What about that? Is that an easy number? Probably not, because now we want to find the local oscillator. I'm sorry, we will want to tune the radio. No, I just messed that all up. Let me think it through again. I'm not thinking straight. So, in order to check the local oscillator frequency against the position of the radio, let's put this on a known position. So I'm going to dial in 30. So there's 30. So we should find it at 35.2. So we look for 35, that's over this way, 35.2. Have I got this on Zoom or something? No. 35.2, oh well, we'll be right in this area here, and there it is. But see, it's not 35.2. Okay, so what that means is there is some need for alignment to make the dial correct. If there's need for alignment to make the dial correct, there's a chance that the alignment is what's causing the weakness in the radio, the poor alignment. I've done the IF, I did not attempt, I've done the FM detector, I did not attempt anything with AM yet. Did I? I don't think so. So all this is saying, do an alignment on the AM side of things, and maybe everything will be working really great. Maybe. Okay, so the next step would be look at the instructions for doing an AM alignment. Okay, this is what I'm talking about here. Realignment of the RF section. Test equipment needed. Standard signal generator modulated 30% of 400 cycles per second, having an output impedance of 75 ohms and covering a frequency band of 19 to 165. Well, I almost get there. Output impedance is 50 ohms on my machine. It won't matter, I don't think. And the frequency band, you know, my signal generator claims to go up to, oh, No, I'm reading it wrong. 50 megacycles. That's where I thought. That's the top of where I can get to. 50 megacycles covers. You can find that on band 4, halfway up the radio. So I can get a fair distance with just my usual signal generator. Output meter matched to 2.5 3 ohms. I don't have that, but what do you got to put a resistor in there to make that happen? And this number is no longer valid anyway because I have a different output transformer now. So this is, we don't know what this number should be. Guessing it's 8. Just have a speaker connected and put the output meter across it. Trimming tools, yeah, I got so many I don't know what to do with them. So here's the instructions. Holy smoke. So I'm not going to read this to you. You're not interested in that. I'm going to read through this myself and we'll pick out maybe some interesting or critical stuff that I got to take into account when I'm doing this thing. I can paraphrase it. Okay, look at this. The first step is to check the accuracy of the dial calibration by making use of the built-in 5 megacycle crystal calibrator. We should try this. The top cover of the RF section on which the calibrator is mounted can be replaced temporarily so the calibrator can be connected into the circuit. Why is the top cover off the RF section? When did that happen? Okay, well, anyway, the top cover's on everything's in place. The check should be carried out with the mode switch at narrow FM using the built-in meter. Built-in meter. Verify all the checkpoints on each range in turn, noting the settings of the cursor shift control relative to its mid-travel position. If full correction is obtained with the control close to mid-travel, realignment of local oscillator circuits will not be required. And you can proceed immediately to the alignment of the RF and mixer stages. Well, that sounds good. Inability to correct the calibration by use of the cursor shift indicates realignment of the appropriate circuits is required. Now, we'll take a look at this cursor shift thing, and we'll try this 5 megacycle crystal calibrator. Let's give these two things a go. So the cursor shift control is this knob here, and what it does is it just displaces the cursor back and forth. You can see the mechanism right here that's doing it. So you want it in the, I would say normally in the neutral position. Where's that? So this is one extreme here, this is the other extreme here, just looking at this thing. Oh no, this is another extreme. So it looks like straight up would be the middle, right in here. So what they're saying is, if you can accommodate your, if you can make the pointer accurate by turning this, then there's no need to do any more. Just turn this, make the pointer accurate, be happy. That's what they're saying. Let's turn on this 5 megacycle thing. We'll see what happens here. I mean, we're not hearing anything right now. It's supposed to be on narrow FM. You hear something now. You push in the calibrator. I think the radio is supposed to go a little quiet. Okay. As we tune the calibrator, we should hear it. Hey, the meter's working. It's in a funny spot though. So as we go across any, like 30, we should hear it. Or not hear it, but know it's there. I can see the pointer move, but it sticks, right? So you can see how close you are to 30 here. So the question is, can I do that? Yes, I can do that. So now it's right on 30. So if we run down to, is there another? 35. I wonder why you do this with the, there it is. Right on the 35 now, because I've made the adjustment. Okay, we'll try another band. We'll try the band above, band 4. There we go. And we could tune in 50. There it is. And we could tune in 45. it is. And we could tune in 40. And there it is. Very consistent. Let's keep going. We'll go up to band 3. And we could tune in 60. There it is. Right on the money. 70. Notice there's like a sideband thing happening here or something. So at this point we'd have to adjust just a wee bit. Like that. Like this, I'm looking at it with a parallax error here. There. Okay, let's go up another band. We'll go up to band 2. 100. Behaving a little different here. It looks like that would be the spot. 100 is 90, 95. A little off to the side. I'm guessing it's between the two hisses. 95. Yeah, we can still get there. And band number 1. Ooh, get on there. There we go. Band number 1. We could go almost anywhere here. 40, 35, 30, 25. Is that it now? I thought it was the guy. You should see the meter go flying, but the meter's stuck up high. Is it stuck? I don't know, it's up high. I don't know why it's there. Why would it be there? I think the meter's stuck. So I say 130. So I don't know for sure, because you'd think the hiss would be it, but that's not how it behaved on the lower bands. In any case, very close and within the range of the adjustment up here. So I think we're going to take their advice and not do any of that. And I don't plan to do any of the adjustments on the tumbler. That sounds like a monstrous task. So there is some more left though. Let's go back and look at what's next on the list here. Oh, for crying out loud. Again? They're just... What is it you want? What do you want? You want to spend some time with me, eh? Is that right? Is that what's happened here? Okay. Maybe I'll take a little break and play with these guys. This guy, anyway. I think his brother's sleeping somewhere. He's rubbing on the camera. That's not the best thing. Cat's not on the camera lens. Okay, yeah, I'm going to take a little break here. He's showing you his rear now. There it is. See what's missing? Okay, so if you conclude, as I have, that the oscillators do not need to be realigned, then you skip right down to here. Now continue with alignment of other ranges using alignment points, no, down to here. Once the scale accuracy has been checked and corrected as necessary, alignment of the signal frequency circuits can be commenced. Disconnect the crystal calibrator from the aerial input and connect it in its place a standard signal generator having an output impedance 75 ohms, mode switch to CW, connect an output meter to the terminals and set the tuning to 26. I can do this. I have the stuff to do this. Let's just skip ahead. So here's a table. L3, L6, adjust turn spacing. Yikes. Yikes. That's a pretty uncomfortable operation. The rest of them, though, are slugs, or trimmers. Trimmers or slugs. So, well, I can do this. Maybe this is where the weakness is. Tune the generator 26. peak the aerial trimmer on the front. Check the trimmer tuning point falls well within its capacity swing. Then peak the appropriate preset mixer trimmer. So you want the antenna trimmer set either in a sort of a central spot or just where it's strongest if it seems to be operating okay. That makes sense? Peak the appropriate preset mixer trimmer. What do you mean by preset mixer trimmer for maximum output? Now tune the receiver and generator to 21. Adjust the core L17. Check the tuning point aerial trimmer found on the line near the extreme of swing. Adjust L16. Blah blah blah. Realign. Do this thing. Sensitivity checked. Should be on the order of what's in the table below. That's what they're saying. To get 50 milliwatts output, you should find you need to put in this kind of signal. It's all 2. It's all 2. Okay, doubt I have to make these kinds of measurements for any, but ultimately maybe because the radio is weak. I have to convince myself it really is weak. Maybe I just got really crappy antennas on it all this time. So select each of the other tuning ranges in turn, repeating the procedures detailed above using the alignment, frequencies, etc. given in the table which follows. Noise factor measurements can be made upon completion. Typical figures being given on page 3. We're on page 20. That's the end of it. This is the last thing. So this is my only hope, is that doing this is going to boost this radio up. It might. So we'll start with this guy right here. So in the middle of me just getting the radio ready for the next step, suddenly it's working way better. How can this be? So I've dialed in 26 megahertz, which is what they recommended, and switch it to AM, expecting it to be silent, as it has been, but it's not silent. And then so what happened here? Just leaving it running for a long time has sorted something out. So I'm going to go to 27. I am on the outdoor antenna, am I not? Just absolutely, yes I am. So the CB stuff is come and go. That's what I'm trying to pick up here. That's an odd thing there. Okay, I'm going to go and check what's happening on my CB radio, if there's anything there to pick up. And okay, there appears to be people talking on channel 9. What is the frequency for channel 9?
Hey Jim.
Hey, what's the frequency for CB channel 9?
That would be 27.065 megahertz.
27065. Thank you. She's gone. 27. Right up in here. .27065. It's got to be right. They're coming in loud and clear on the CB radio. On channel 9. Ooh, what happened there? Did I pump something? Well, we're definitely not picking them up. Let's try this. So 27 appears down here too. Let's try the other band. So that would be band number 5. Quiet. Just makes that noise. 27. Here we are. I don't know, do you think that's a carrier? I heard a voice. Where'd you go? Oh my. Oh, this is really picking up the signals. Picking up the noise anyway. Gee, can I switch to the width to the 102 centimeters antenna and get it on down here? That's a tough one. But look at how well it's working. Like, I never produced this noise before. Is that the secret? Just leave it on for a long, long time and it eventually comes around? I need some signals. I need a signal. I need a signal. Where can we get one? 20 megahertz. What a, yeah, not likely. I'd have to get another radio. 20 megahertz is where we would find WWV, but I'm not so sure there's any chance of that. Wow! Is that some powerful noise? Then it just drops out. So frequency wise, 23, 24. Oh, is it this? Yes, it's just the trimmer, Jim. You gotta keep an eye on that. Okay, we'll try up here again. Come on, man. If I put it on CW, it'll bring on the BFO, and we'll know if we're getting carriers here. Supposedly. Assuming that works. Nothing. Huh. Could just be my antenna just doesn't do the trick at this frequency. A long, long, long lead-in to get to the shop here. Let's see what else I can do. Okay, how about this long shot? I have a CBC, CB radio right here. How well this one's working, I don't know. What channels is it? It's a 2-channel. Where oh, channel 1, channel 2. Battery's good, it says. I haven't had this on in years. Call. Okay, so this is, we don't know what channel this is. So if I just hit this and tune, we'll see what we find. Ooh. Ooh, yeah. Huh. What's that mean? Okay, let me hold it a little further away from the radio. Ooh. Well, by gory gosh, I think the radio's working. Despite all my attempts to fix it, it has decided to work suddenly. Let's see how far away I can go with this walkie-talkie here. Okay, a little farther. Okay. So this is, I fixed the radio. I don't know how, but I have. Maybe in the course of changing tubes. I get too excited now. You don't know that it's not distorted. We need to resolve the distortion question. I need to tune something in that is going to enable me to judge that. What the heck do I have to do that with? I would like to put some music through it, or something like that. Okay, gotta go figure out how I can do that. Just listen. Come on. So the CB I'm hearing is coming from Puerto Rico. There he is! There it is! This is actually kind of comparable to what my CB radio is doing. My CB radio has a proper antenna dedicated to it. There we go. You know, this radio's working. I have to have the volume up high. I'm going to take that back. It's still pretty distorted. Okay, that's great. Lots of fun happening here. Let's get on with the alignment step. Okay, well, what I need to do now is take this radio back to my listening post, where I do my radio listening, and connect it properly to better antennas and give it a good shot back there, and just play around with it and see, yeah, is this radio actually working? And I've been fooled all along, which I don't think is quite the case, but I think that's what I need to do with it at this point, just to be sure of things. So, yes, another cat here again. Oh my gosh. Well, I'm going to think about that just a little bit, because dragging this back, it's a bit of work. Maybe I should give a poke. Oh, here's the problem. Well, let me show you the problem that I'm facing here. It's not the cat. So this is the table you use to decide what to adjust. Here, listing the trimmers that you need to adjust and the cores you need to adjust. I cannot find any reference as to where these are in this manual. There's no picture showing where you'd find them, and I can't even see them. I'm looking at the radio. I don't even see any adjustments up on top. It all must be underneath. Yeah, so mixer alignment, oscillator alignment. This is not the one I want. This is the one I want down here. Mixer alignment frequencies, I think. But the fact is, I don't know where these adjustments are. Where are they? You're keeping it secret. Secret from me. There's nothing down here. There's just nothing down here. Let me shrink. Can I shrink it? Shrink it a bit. So this would be the place you'd expect to find that kind of information, and I have looked it over. It's listing the transformers here, but there's no list of tuning adjustments, and there's nothing on the top that I can see anyway. So this one is looking at the top. This is looking at the bottom, looking up from the bottom. See, all the tubes are showing dotted lines because they're up on top, And where are the adjustments? Here's one. One adjustment. Where's the rest of them? C91C. This, what are they talking about here? They're talking about two great big filter capacitors here. Very frustrating. Here, down here, they got the adjustments for the transformers. But nothing on capacitors. How can they not have that? Here's some. These aren't adjustable. These are not. Here's one. Here's one. C132. But you know, well, this is in the crystal calibrator, so it doesn't even. I'm not even concerned about it. Oh my gosh! How come they're making things so difficult here? Somebody just left this out of the manual. It's really about all I can really say is that this was an oversight. Just going right to the top. Make sure I haven't missed any diagrams or anything. I don't think so. Well, isn't that silly? I'm talking to my cat here. Do you think it's silly what's happened? What do you think? What were you winking at me for? Yeah, go to the go. Okay, so I don't know what to do at this point, so I'm just going to stop and leave my radio there for now. I do have another simpler radio to work on, just a junker radio really. So I could take this back, do some listening with it, convince myself it works or it doesn't work, and then it could come back down here and it could continue with it. I don't know. I'm lost. I'll have to think it out. Thanks a lot for watching. Sorry the thing is kind of turning into a mess here, but it is what it is. And I am what I am. I am what I am. And that's all what I am. Famous words. See you later. Okay, give it a little more thought. Yeah, I'm going to shuffle this guy back to its listening post and play around with it for a week or two. And in the meantime, I have another old radio here. Wow, I don't know what I'm going to do with this thing. Here, this is the kind of thing I got to take a look at. I mean, this is a transistor radio, I'm pretty sure. And fool around with that for a day or two, and that'll give me time to hook this thing up to better antennas and find out really is it working or is it not, or what is the story with this radio. My guess is it's distorted still. That's my guess. Thanks a lot for watching to this point, and you saw the radio will be in here next for a couple of days while I sort that one out, and we'll see. We never know what's coming in here. I never know. See ya.